recording. All right. All right. Welcome, everyone. It's October already. How did that happen? azPHP, sponsored by Pagely still, even though we're not meeting in person at Galvanize. But, you know, Galvanize is actually still doing their thing, and the mystery machine was parked in front of the building the other day. So it's pretty fun. Spooky goings on. I do see some new names, I think. If anyone is interested in introducing yourself or just letting us know if you're working on anything interesting or have any questions, now's the time. Also, if you are looking for a job or have a job posting.
Yeah, so.
Yeah, I'm Dan. I work actually with Chris. A company called ClearChecks, and we're located here in Phoenix. We are hiring Laravel PHP developers. So if anyone is interested, we have an office in downtown Roosevelt and Central, and combination of that and remote. We're not actually working in the office right now. We're doing a bunch of renovations. So, but yeah, nice to meet everyone.
Maybe after the crapocalypse is over, we could all grab lunch somewhere together.
Mm-hmm. Yeah, and I was even gonna say, you know, I don't know what the situation is with Galvanize, but we're building out a big conference room, and we've got a bunch of stuff. So our space is always open to meetups and stuff like that in the evenings as well.
Yep. Yeah, they're starting to do meetups at Galvanize again, but it's still pretty empty there.
Are they still limiting numbers for attendees and stuff?
Probably. I haven't really asked them again yet. Haven't even bothered. I figured at this point, the rest of the year,
yeah,
whatever.
At this point, we might as well just stay online.
Yep. All right. I did not have a chance to come up with any trivia.
So I'm Chris.
Oh, yep.
I'm the manager of operations at Resound. We're a branding agency, but for some reason, everybody wants us to dev their stuff. So we end up doing, we have some pretty good relationships, and we are looking for one or two developers. We work mostly in Laravel. We have and I know last time I was here, there was mixed emotions about Laravel.
That's mostly from me.
Okay, all right.
But I'm actually familiar with you guys. I'm based out of Mac 6 as well.
Oh, you are? No way. All right, cool. Yeah, we just moved downstairs to a suite. So yeah, awesome. Yes, I remember you. You're relatively new in the space, right?
Yeah, I just got in there in June.
Right on. Well, so we'll probably chat with you, maybe, unless you just hate Laravel.
I can do Laravel. I just avoid it.
So Laravel, just the normal stuff that surrounds that. We end up working a lot in WordPress because we build our designs on Divi, and then and so we end up with a lot of like customizations that clients want on the back end to do special tricks. And so we have projects with donor dashboards. We work with Virtuous, Paperless, a few other integrations with payment processors, and then some upgrades. So you guys were talking about doing a lot of upgrades. We're doing some upgrades for clients right now too, server upgrades with Laravel and PHP. And that's most of the high level stuff. So I'll put my information in the chat, and then you guys can reach out if you're available.
Yeah, and anyone here, feel free. We have a Facebook group that's usually just me posting stuff, and the AZ Devs Slack channel. We do have a PHP channel in there, so come join us. It's usually a fun time. Actually, relatively quiet, but if you have any questions, it's a good place to find someone. I already went over this. PHP 8 next month. Woo!
Composer 2.
Something good to come out of 2020.
Composer 2.
Oh yeah. Composer 2 is out. They updated their Docker Hub image and broke our builds for a little bit until we that. It's all right. We'll get it fixed. It's just it's the plugin architecture needs to be tweaked to sync up with V2, but that's all right. Unless anyone else has anything, we'll just get right onto it. I'll let Chris take it away.
All right. Let's make this thing work. Can you see?
Yes.
All right. Hello, everybody, and welcome to my presentation, Don't Fear the RegEx, crash course in regular expressions. And I know they're kind of intimidating when you look at them from the outside, not knowing what they are. So I'm hoping to kind of alleviate some of those fears. I'm Chris Kankiewicz. As we stated earlier, I work at ClearChecks with Dan over here. He's my boss, so be nice to me. You can find me on GitHub at Flack on GitHub, also on Twitter. Feel free to reach out to me on either of those platforms for whatever. So let's start, for those of you who don't know, by defining what a regular expression is. Textbook definition might be to say that a regular expression, or RegEx, as you may hear, is a set of literal and or meta characters that compose a search pattern for matching strings. Great, now we're all experts. Hold on one moment. Get my notes up here. Yes, I'm sure that was a totally clarifying definition right there. You're all caught up. We're good to go. But really, don't panic. It's one of those things that's a lot easier to explain through example than it is by any conventional definition. So first off, let's dive into the syntax of a regular expression. Any regular expression is going to need to be delimited, and that means it needs to be enclosed on either side by a pair of matching characters. And those characters can be any non-alphanumeric character, can't be a backslash or white space. Most common of which, for example, is the /. And so you'd have your pattern between the two forward slashes. Other common delimiters include the # or £sign or number sign or an @ sign. But again, it can be just about any character besides those that we already said it can't be. In addition, you can have modifiers to your regular expression patterns. Those are also known as flags. And these can be added after the closing delimiter, and these can change the functionality of a regular expression. Two of the most common ones you'll see is the I modifier to make the pattern, the regular expression pattern case insensitive. By default, it is case sensitive. Or M, which means treat each line as individual lines, but we'll kind of get into more exactly what that means in the future. For a list of more of them, you can reference this link here. But for an example, this is what it would look like to use them. You can, after the closing slash, you would have I or M, or if you wanted more than one, you just combine them one right after the next. Let's dive into the patterns themselves and like how we actually use a regular expression. First of all, you can match literal text with a regular expression, and this lets you match one or multiple literal characters. That is, if you give the pattern A, it will match the letter A. It will match an A in a bigger string of text like face, but it won't match an invalid casing, example, a capital A. It won't match a B, a 3, an exclamation mark, won't match a string without that letter in it at all. Additionally, you can then add multiple letters, make whole words. So Bart will match the word Bart. It will match Bart within the full Slarty Bartfast, but it will not match capital Bart, Lisa, 1, 2, 3, etc. And you can match numbers, of course, just like their character, just like any other. And non-string characters as well, like dashes. Sometimes you may need to actually match characters that aren't actually printable, non-printable characters like tabs, carriage returns, line feeds. The most common of which you'll see are here, tab. If you need to match a tab, you can use \t. You need to match a carriage return, \r. You need to match line set feed. Yes.
You're going to robot mode.
Let me get my other headphones. One sec. Can you hear me?
Yeah.
Okay. All right. So non-printable characters, obviously you can match with the special characters. That is, like I was saying, tab would be a \t. You need to match a carriage return, \r, line feed, \n. There's a lot more non-printable characters, but these are going to be the most, some of the most common and probably the only ones we'll be using tonight. Within a regular expression pattern, you're going to have multiple meta characters that have special meanings. We'll get into their actual meanings in a bit. These are the characters that meta characters that the PHP regular expressions use. If you need to match those characters literally, you'll have to escape them. That is, precede them with the / followed by the character itself to match those characters literally. Now, obviously, you're not always when you're using a regular expression, you're not necessarily just matching text. That would be more or less just a straight up search or find operation. You actually want to when you use regular expressions, you're trying to match patterns in ways that aren't normally expressed in literal text. So first character you're going to learn here, the first meta character is the dot, and that will match any single character except a new line. So for example, it'll match A, B, capital, lowercase, numbers, symbols, whatever, but it will not match that carriage return or new line like we saw. Sometimes though, you might need to match more than one character with constraints. So for that, we can use character sets. For example, to define a set, you define a set by surrounding the characters you wish to match in square brackets. So this pattern here, we're going to look for a capital A, lowercase b, or the number 3. We'll match capital A, lowercase b, or number 3, and won't match anything outside of that set of characters. In addition, we can match a range of characters. That is, we can say from this character to that character inclusive. So for example, to match any digit, we can say in square brackets 0-9, and that will match the characters 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Won't match text, symbols, etc. Similarly, we can match a range of characters, either uppercase or lowercase, by giving them the same pattern. And for a more practical example, you can see here if you want to match the word gray, either alternate spelling gray or grey, we can give it the pattern gr, a set of a or e, y, and that will match either gray or gray with a or e, but not other characters like an o. Now you can do just the opposite of that and match none of the characters in a group or range through a negated set. Negated set is defined with square brackets and then starts with a caret. So if we say, if we make a negated set of capital A, lowercase bc, it will match a lowercase a but not a capital A because that's part of the set. It will not match the lowercase b or c but capitals, and obviously other things like numbers and symbols. Similarly, we can match a negated range of characters, or in this case, digits. And this is, again, kind of a more practical example. We want to match any word ending in OOL that is not started with a capital or lowercase f, so therefore it will not match the word fool, capital or lowercase, but it'll match cool, pool, tool, and so on. Sometimes though, you want to match more than just a single character, and for that you can use one of the ways of doing that is through alternation, and that is it's going to match the first complete pattern from left to right. Think of this as an OR statement. In this case, we want to match the literal word Arthur, or the literal word Ford, or the literal word Zaphod. Match Arthur, Ford, Zaphod, but not Marvin, because that's not part of the alternation set. But let's say, for example, you want to match the phrase cat food or dog food. You might think to do something like this: cat or dog food. Unfortunately, what that's going to do is capture everything on the left side, cat, or everything on the right side, dog food, but not the literal cat food. In order to capture cat food or dog food, you can constrain your alternation by surrounding it in parentheses, and this will match either the word cat followed by food or the word dog followed by food, and that will get us cat food or dog food like we wanted. Sometimes you need to constrain your patterns even further by saying, I'm looking for some text that is either at the start of or the end of a string. And to do that, we can use anchors. For example, if you want to match a pattern at the start of a string, you can use the caret to indicate the very start of a string. And this will match, for example, the pattern art, as long as it's at the very beginning of the string. So this will match art or Arthur, but will not match Dart, because art in this case does not start the string, and particle does not start the string. Similarly, you can match the end of the string with a $sign. This will match art at the end of a string. So art again literally will match because it is the only part of it and ends there. Dart ends in ART, but Arthur and particle do not. And of course, you can combine these to say I need it to both start and end with this exact string, so that will only match art and none of the other patterns with art within the text. Similar to your string delimiters, you can match something called a word boundary, and that's it's a little vague, but it's actually a position between a word character and a non-word character. For example, if we want to match Ford, the term Ford, but with a boundary is defined \b. We can say we're looking for a word boundary and then the word Ford, and that will match the start of a string, or okay, this isn't the best example, but it would actually match, for example, if there was a space, like something space Ford, that would match, but it would not match, again, the word within it, because there's no non-word character between these characters. Similar to that. Same thing, but with the boundary at the end of the line and on either side. I realize this isn't the best example. And sometimes, instead of typing out every character you want in your sets, you might want to kind of reduce your overall pattern by using shorthand classes, and those can be again defined with backslash and then a character. It's like \d is any decimal digit that's equivalent to the set of the numbers 0 through 9. H and V are horizontal and vertical white space respectively, or /s is any white space character, includes space, tab, new lines, and then one of the most common ones you'll see also is the \w, which is any ASCII word character, and that is any capital or lowercase character, the numbers 0 through 9, and an underscore. And then just a quick note, the vertical and horizontal white space, these aren't the exact matches, but for our intents and purposes, that's all you need to know. There's actually a number of additional characters there that would be included as part of those shorthand classes. Quantifiers. Sometimes we need to repeat our patterns or give them a quantity to be matched.
Chris, your audio cut out. Horse is really quiet now.
He's just really quiet, yeah. Can you like draw on his screen? I don't think you can hear us either.
pattern
Yes.
is, in this case, the letter S is optional. So that will match either plural with it. More practical example is you want to
Stop
capture both the English
talking.
and British spelling of the word color, which sometimes has that. I put that on the wrong character. That should be on the U. Or no, COLO. Yeah, COLOUR. So this should be following
Can
the
you
U.
hear us now?
But the U is in
Yeah, he's
fact
still down.
optional, not the O. But that would then match the word color with or without the U. Repetition. If we need to match more than just a single optional character, we can match 0 or more, 1 or more of the 0 or more, 1 or more of the preceding patterns. In this case, I'm getting a little complicated on you and writing some more complex patterns here, but hopefully you can still follow. So in this case, we're going to match the literal capital character, or we're matching the capital character A to Z. Oh. How do I sound?
Better.
Nope. I assume he's rejoining.
No, he just said, screw it. I'm done.
Oh, Zoom.
Was anyone else the presentation out of sync for everybody else?
Not really.
I feel like it was.
It was lagging like 2 or 3 seconds behind what he was talking about for me.
Yeah, I mean, I was lagging like 10 seconds. That's why I reconnected to see if I could improve that.
Hello.
I hear.
Right. Set my Zoom. I don't hear anything.
What about now?
Give me a minute. I'm gonna reboot.
Yay, technical difficulties.
That's the way of things.
You're going to cut this part out of the recording later, right, Gordon?
Nope. No, I can do that. That's fine.
Okay, I can hear you on my laptop.
azPHP, live and raw.
That's right.
I can hear you on my
Hey, we can hear you.
Okay, you can hear me?
Yeah.
Yeah.
All right. I can hear you to some degree now, at least. All right. All right.
Or you have to make them a co-host.
Technical difficulties. All right. I'm just going to go with it, with what I got. All right. Back to where I was. Where are my notes? Okay, so repetition. Sometimes you need to repeat the patterns that you were working on. So in this case, we need to, we're looking for a capital letter followed by one or more lowercase letter. The plus sign means one or more. So that will march things like
Are you sharing your screen?
Oh, I'm not sharing. That's right.
Here it is.
Good. Okay. All right. So we're going to match one or more character with the plus sign. Additionally, we can match 0 or more of the preceding pattern with an asterisk. So this is going to match capital A followed by 0 or more lowercase
It's just
letters.
me, or I don't hear Chris.
You don't hear me?
No, I can hear you.
I can hear you.
Okay.
You might need to reconnect. Good old Zoom problems for everybody.
All right.
But I think you're good, Chris. Keep going.
Okay. So with the asterisk, we're going to match 0 or more of the preceding patterns. In this case, 0 or more lowercase letters. So in this case, it will match the literals A and F without any following characters. And a practical example of this is if you want to match some hexadecimal code. So we're going to look for a pattern of 0x followed by the characters 0 through 9 or A through F, and one or more of those. This will match any valid hexadecimal notation here, but it won't match things outside of that pattern, including X, and it won't match something without any digits after the X, the lowercase x. And instead of saying one or more or 0 or more, you can give actual specific quantities to these. To do that, you define it with a number within curly braces. So in this case, we're going to look for 2 H's, G, 2 T's, G. So that will match HHG, TTG, but not less than 2 or more than 2 of those patterns. Similarly, we can say, I need to match one of the pattern 1 to 3 times inclusive. So in this case, we're looking for no with 1 to 3 O's in it, and that'll match no, 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 and not N or too many O's. But keep in mind, by default, quantifiers are greedy and will match as much text as they can while still adhering to that pattern. In order to adjust this, you can use a question mark after the quantifier to make the quantifier ungreedy, also known as lazy. And an example of that here is if you want to match let's say you're trying to match a HTML tag of strong, you might create a pattern like this that says starts with a open chevron, any character, one or more of any character, closing chevron. Unfortunately, this isn't going to match just this single pattern. This is going to go the whole way and match all the way, because this whole string would match that exact pattern. In order to make that lazy and constrain that, we add a question mark after the plus, and that will match the least possible, but still adhering to that pattern. Groups.
Quick question, actually, on that last one.
Okay.
The second pattern, would that also match the /strong?
It will not. Yes, it would, because it's any character. So I haven't gotten there yet, but depending on your, I'm going to get into the actual PHP functions in a bit. when your most regular expression patterns will match the first occurrence of your pattern and nothing more, but there are other options to that. So if given this exact pattern, the first match that would come out would be this, but not this. But technically, this part of it would also match this pattern if you were matching more than one, looking for more than one matches.
Okay, thank you.
Grouping. Groups allow you to apply quantifiers to subpatterns or to constrain alternation. So let's see, in this case, we are getting even more complex. We're creating a group by surrounding any subpattern within parentheses. In this case, we're going to look for capital or lowercase h followed by o, that is ho, and we're going to group that whole pattern and look for that whole pattern 3 times, followed by an exclamation mark. So we're looking for that will match something like ho, ho, ho. And then similar to before, if we wanted to match the terms baseball or football, you have to add the parentheses around your alternation to group them. This will match base followed by ball or football by ball, aka baseball or football.
In your first example there, wouldn't you also need a space in your group?
Yes, you would. I don't have a space, so this wouldn't actually match that without a space. Let me tell you, coming up with examples was the hardest part of this presentation.
No worries, you've done great so far.
Capturing groups. So you can capture the result of a subpattern as a numbered group just by giving it a parenthesis, surrounding it in parentheses. So for example, we surround any character, one or more of any character, capital or lowercase, space, any character, one or more. And we're wrapping both of those in parentheses. So with this pattern, you're saying I'm looking for 2 groups of any characters, basically, with a space in between. So given the subject Arthur Dent, our 0th group, our very first group, will always be the complete match in any capturing group. And then the first group will be the first pattern here, the first grouping here, which matches Arthur, and our second matches Dent. Sometimes though, you just want to group a pattern, whether to apply a quantifier to it or just to kind of mentally separate it in your head and say this is all part of one group without capturing those results. For that, you can use a non-capturing group, and it's the same thing. You wrap it in parentheses, but at the beginning of the parentheses, you add a question mark semicolon, and that says this is a group, but we're not going to capture it. So when we get our groups out at the end, again, we got 0, which matches our full pattern, forward prefect in this case, but our first group is going to skip over this one because it's a non-capturing group, and this becomes our first group. So that one will capture prefect. But numbers don't necessarily mean much. So sometimes you want to give your group a name, and to do that, we can capture the result of a subpattern as a named group. Same thing, you wrap it in parentheses, but to name it, you give it a question mark, and then within an open close chevrons, the name of the group you want to give it. So in this case, I've created 2 groups, one to capture the first name, and we will call that first, and one to capture the last name, we'll call that last. Given the subject Zaphod Beeblebrox, we'll capture 0th group, which will be our complete pattern, followed by group first, which contains Zaphod, and group last, which contains Beeblebrox. Back references. Sometimes you need to use the result of a previous group as part of a pattern later on in your pattern. Kind of complicated, I know, but it's not that bad. For example, if you want to capture a HTML tags and the content within it, you need to know, you might not know the actual tag you're trying to capture, but know you want to capture the tags and all content within. So in this case, what we're going to do is we're going to first create we're going to capture an HTML tag that is open close chevrons, but inside will be any, in this case, we're just going to say any lowercase character, one or more of any case character. And we're going to group that, the characters as we're going to create a group out of those characters. We then capture any text ungreedily, and then here we define our back, and then we're going to look for a closing HTML tag that is open chevron \, remember or forward slash. Remember, forward slash is a meta character, so we have to escape it with a backslash. So this is actually just saying right here, just capture the forward slash. And then we're going to, \1 is a back reference to our first capture group. So this is going to say, whatever this group captured, look for that same thing again here. So this will match something like strong, azPHP, small, node az, small, because those have matching tags. But if you had mismatched tags, aka strong and strong, you will not capture that. It would not match that. Look aheads. Sometimes you need to know if a pattern has a sub pattern before or after the main expression you're trying to catch, the main pattern you're trying to catch, without including it in the results, that is. For that, you can use look aheads. All right, this one was a little complicated. So for this, we're looking for the name Arthur with or without a capital A, and then we're creating a look ahead, a positive. This is called a positive look ahead. That is parentheses starting with question mark equals. And what this says is look for the following pattern later in the subject, but we're not going to capture it. So this would only match if we have the name Arthur followed by the name Dent. So it will match Arthur Dent, but not Arthur Prefect. And then the capturing result would only be Arthur in that case, because it does not capture the look ahead. The opposite of that is a negative look ahead, and that's defined parentheses with question mark, exclamation mark. That says capture. So we're looking for Arthur as long as it's not followed by Dent in this case. So it would match Arthur Prefect, but not Arthur Dent. And again, the results would only be this part. And then we've got a look behind, which is same thing, but saying look for this part ahead of the rest of it. So we're saying look for, so we want to find a match of prefect only if it begins with Ford. That will match Ford Prefect, but not Arthur Prefect. And it will capture only the non-look ahead part of that. And a positive look, that was a positive look behind. And then the negative look behind is the opposite of that, saying only do it if it doesn't contain that. I misspelled that. Complicated, I know, but when you break it down, it's actually not too bad. But that's the whole point of regular expressions. They kind of build on each other. Every single thing you build and build and build to make these complex patterns to match the text you want. Regular expressions. So let's talk about regular expressions in PHP. PHP utilizes a Perl-compatible regular expression library. That is, the PCRE library is a set of functions that implement regular expression pattern matching using the same syntax and semantics as Perl 5. I've never actually used Perl 5, but this is supposedly exactly how that works. You can read all about that at pcre.org if you want to actually delve into the actual PCRE specification and stuff in depth. It's not a big deal, just as long as you know, and if you're working with regular expressions and you need to know what engine it's using, PCRE is the engine that PHP uses under the hood. The PHP SPL includes several functions for working with these regular expressions. Currently, they're all going to start with preg, however you want to say that, underscore. Back in the 5x days, there used to be ereg functions, but those are no more. But if you're still working with 5x code, you might see those. But I think even back then, preg was pretty much the standard regular expression functions you would see. And here's a group of them. You can find more on php.net in the manual. But let's take a closer look at a couple of them. First off is the pretty straightforward preg match. This takes a pattern that's a string and a subject that's a string, and then this optional pass by reference variable matches, and it will return an int. So what this does is it searches the subject for a match to the regular expression given in pattern. That is, pattern is a regular expression, subject is the body of text you're going to search through for anything matching that pattern. If matches is provided, that is, again, it's an optional parameter. If that's parameter, if it's provided, that variable will be filled with the results of the search. and this function returns a 1 if the pattern matches the given subject, or a 0 if it does not. That's important because you may need to use, you should be using strict comparisons anyways. If it fails, I believe it returns false. So make sure you're using strict matches or strict checks when you're doing like a check for that. So let's check an example. So given the subject string, Serious Cybernetics Corporation, we're going to look for any pattern, look for the pattern of a capital or lowercase c followed by any text, any lowercase characters, one or more of those. We plug that into PRegMatch, and we're going to go ahead and pass it the matches variable like we said. And PRegMatch will return 1 because this does contain a word that starts with capital C and ends in lowercase letters, one or more lowercase letters. And for that is cybernetics, but it's also corporation. And this goes back to the question from earlier. PRegMatch, we're gonna let's look at the actual what actually dumps out in matches. So matches will return this goes back to our groupings. So the very first thing it returns is the complete match for that pattern. And like I said before, it's only going to match the very first thing the very first thing that matches that pattern will be the match. Even though this pattern does match both cybernetics and corporation, regular expressions operate from left to right on the subject string and will match the very first thing they do. So in this case, the full match is cybernetics. That matches the whole pattern. However, we're then including a capture group of just the lowercase letters here. So that second item within the matches array will be just that group, cybernetics there. Now, if you do want to match every pattern or get every match of a pattern in from your string, you can use PRegMatch all. And then it's the same, otherwise, it's the same parameters. You get a pattern, a subject, matches, and an integer. This will searches the subject for all matches to the regular expression given in your pattern. If matches provided, it's filled with results of the search and returns a number. And then this is different. It will actually return the number of full patterns matched, and that could be 0. So similarly, you're going to want to check be specific in your checks against that if you're actually checking the return value there. And an example of that: given the subject string, how much wood would a woodchuck chuck if a woodchuck could chuck wood? And we want to PRegMatch all against that. Can you still hear me? I feel like
I can hear you, but your presentation's lagging.
Oh man.
I mean, it's lagging for some people, not for others. So I don't know what you do about that.
Okay. So all right. So given the subject string, if we want to find any patterns with wood followed by any characters, any lowercase character, one or more lowercase characters, plug it into PRegMatch. We're going to actually get back 2 results. So the return is 2 results because we're looking for wood followed by one or more lowercase characters. In that case, we've got woodchuck and woodchuck again. And then we're going to return, we're going to get back our matches, and matches in this case will be 2 arrays where the first one is every complete match, woodchuck and woodchuck, and then the group matches, which in this case are just going to be the lowercase letters following wood, so chuck and chuck. Our next example here is PRegReplace. PRegReplace searches the subject for matches to pattern and replaces them with a replacement. So basically, this is looking for some text, but using a pattern to do so, and then replacing that with some other text. If matches are found, the new subject will be returned. Otherwise, the subject will return unchanged. So let's take the example PRegReplace, and our subject string is John Pinkerton. We're going to look for the term pink with or without a capital P, and we're actually going to capture that letter. And we're going to this is something special you can do with the replace, is you can actually use those back references to fill in your replacement with back references. So we're going to replace either the capital or lowercase p as is with itself and replace the rest with ERPL. In this case, given this pattern and subject, we're going to return John Purplerton. Another useful one that I've used in the past is replacing all you can use a negated set. In this case, we're going to say all non-digit characters we're going to replace with null, or you could give it a blank string as well. And it's going to basically strip those out of it. So given a phone number, let's say we want to strip out any non-digit characters, we can say, given the pattern, all non-digit characters replaced with null, and that will give us the output string with only digits. What was this? Oh, another p-reg replace example here. Another one I've used in the past is we want to convert one date string to another. Given a date string of month, day, year separated by slashes, we can search for those. And something you'll notice here, I actually use the hash symbol instead of a forward slash to denote as a delimiter here. The reason I did that is because my string itself literally contains slashes. So instead of having to escape those and put backslashes in front of it, I just changed my delimiters instead. So my pattern here is going to look for 2 digits followed by slash, 2 digits, slash, 4 digits. And then we're going to replace those with the third group dash first group dash second group. And that's going to convert a date like 05/20/1986 separated by slashes to 1986-05-20. And then also with p-reg replace, you can pass it an array of patterns and then replace an array of replacements as well. This is just an example of that, showing that given these patterns and these replacements, we can do kind of the same thing, but with you have multiple options of what you're going to do there. I won't delve into that too much. Lastly, probably one you won't use a whole lot, but I've used in the past in a little bit. It's not a bad one, but you can split strings with p-reg split. This will split the given subject by a string matched by pattern. So an example of that is we want to break apart, again, a phone number, but it might have spaces as separators, might have periods as separators, might have dashes as separators. So what we can do is say, look for any space, period, or dash, and split that string based on that pattern. This will result in the array 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the last function to note here is the p-reg quote function. And this escapes regular expression characters from a string for you. So you don't have to manually escape those characters especially when you're trying to do this with dynamic text. It's very useful. If the delimiter the optional parameter delimiter is specified, it will also be escaped. And it returns the escaped string. So for an example of that, given the text foobar with your square brackets and a plus sign, which are both regular expression meta characters, it will return those characters preceded with backslashes to escape them. And then similarly, if we pass that second parameter, that is the delimiter, if those delimiters appear in the pattern, in this case, if we're using forward slash as our delimiter, and we're trying to do a pattern on with a file path in it, we want to escape those so that they don't those literal forward slashes aren't treated like delimiters, and so that'll return those escaped for us. And now we're all geniuses and experts on regular expressions. Okay. Exercises here, but this requires back and forth, so I wanted to have everybody participate. Can we, I don't know, how bad is it? Am I laggy? Can you hear me? Can I hear you?
Can you hear me?
I
You
hear
can
you.
caught up for me now.
I can hear you fine.
Okay, I can hear you. Can you see me? Can you see things?
Says exercises, yeah.
Yeah, okay. All right, I think this might work then. All right. So let us do an exercise that is match a phone number. So given the following set of strings, which are mostly phone numbers, let's find, let's write a regular expression pattern to only match US phone numbers in various supported formats. That is, any of these strings should pass the regular expression, should match, and any of these should not match the regular expression. So let me open this. This is, can you see this screen that I've got open here with the, can you see like exercises, US phone numbers and the expression?
Yep.
All right. This is one of my favorite tools called regexer.com, RegExr.com. It's a great tool for when you want to write and test regular expressions. Essentially what this gives you is up top here, you write your regular expression. Down here, you can give it any text and it will highlight what it matches. Down here, it has some descriptions on what matches and the details of what matches and stuff. We'll go into that in a little detail later. For now, we're gonna hide that. But what I've done here is I've moved over our phone numbers. And these are those are the phone numbers we want to match, and these are the phone numbers we do not want to match. So maybe, okay, I think my plan was to kind of go over this one mostly on my own, but if you guys want to provide some feedback, or maybe I'll just ask some questions as we step through it. But essentially when I approach a pattern or writing a regular expression pattern, my first step is to gather the formats that I know I need to match and some I don't want to match, so that way you can test against those and know what you're working with. And then the first thing I do is I pick one of the good matches that I want to match, and just one of those formats, and write an expression for that. In this case, I think the easiest one will be this. So how would you match a phone number that is just a string of text, or string of numbers? Anybody got an idea? Anybody want to participate?
Do match digits that is exactly 10 digits long.
Okay, do you remember?
/d,
yeah.
Open curly brackets, 10, close curly brackets.
Bingo. And as you see, it's highlighted that string to indicate that it in fact does match that string. Great. You wrote your first regular expression. Thumbs up for you. Unfortunately, it doesn't match most of the other patterns we want it to match. So what could be a next step here? For me, I was going to move on to try and match the this pattern. It doesn't seem that much different from this. It's the same 10 digits. They just happen to be separated by some dashes.
I would do it as a group probably, and so do a switch between that first pattern and then group the next one that you want to match.
Okay. Can you? So you would say, oh, you're saying say do this or another pattern, or like the next pattern?
Yep.
So okay. What would that next pattern be in this case?
So \d curly brace 3 close curly brace dash
Yeah, through D3, then D3, then D4.
or
But I think if you just put question marks after each of the dashes, then basically making each dash optional, you can get rid of the first version.
Think you can get rid of that?
Yeah.
Yep, pretty much. That's exactly it. That would have been my next step too, is instead of trying to match all 10 digits at once, we're going to instead break it down and say we're looking for 3 digits followed by an optional dash, 3 digits, optional dash, 4 digits. And yes, that will match either of those. However, if you see, this is now starting to match our one of our unwanted patterns, but we'll get to that later. Don't worry about that.
The dashes
Next,
could also be spaces, I guess, if you want to make those into groups.
okay, so you're saying change these into groups, the dashes into groups?
Yeah.
Or I think what you're looking for is a group. So you're saying
Yeah, so parentheses,
this
I guess, and then a pipe, yeah. And
or
then
that
I guess dash or \S, yeah, spaces.
or space. We'll just do a single space. A literal space does work. That's not bad. That's definitely working our way there. Where was that? Okay. Wait, did I miss a step here? No.
Yes. So
Okay.
the one at the beginning, I guess put a plus at the beginning with a question mark since it's optional.
Okay. And that also would have probably the same thing here, right? Could be a space or a dash. So we are currently not matching anything. Why is that? So that's because this whole start part is actually optional, or also that is invalid because that needs to be escaped. Yes. Okay, so that does match our +1 string.
Could you wrap that entire first group in parentheses again?
Exactly, you can do that. So we could say this whole thing is actually, let me reference my notes. I think I did, yes, this is optional. Or no, yeah, it's that whole thing is optional. I guess, again, I don't think I said this yet, but when writing a regular expression, there gonna probably be multiple ways of getting to the same answer. So don't think you're doing it wrong if somebody says, like for example, in my example, instead of this, I used this, which is just a set of the same things instead of an alternation. But really, like, if it works to some degree. There are some things to note about performance of regular expression patterns, but for most part, you don't need to worry about those unless you're searching like a huge body of text, and that's a whole nother can of worms that I'm not even going to talk about. Anyway, where were we? So okay, so we've made the +1 optional. I think you guys said to make the plus that originally too, didn't you? Okay, so why isn't that matching this one now? What are we missing?
We're missing the parentheses around that first grouping of numbers.
Yep, so that would be right here. So this is surrounded by parentheses. Again, parentheses need to be escaped, and parentheses escaped, and that will match that. But those are also optional. This is one of those areas where you could take the shortcut or the long cut, and that is if you just do it this way, both of these parentheses are considered optional, but you could technically match it with or without either parenthesis. And realistically, that just comes down to what your requirements are for this pattern. For now, I'm just going to leave it like that, but you might have to write a pattern that says it must, if there's a starting parenthesis, it must have a closing parenthesis. Again, that just adds a lot of complexity we're not going to get into now. Okay, so we've matched all of our want to match patterns, but we're now currently matching a couple of our don't want to match patterns. So how can we do that?
Do a $sign at the end and a pointy hat at the beginning.
I think that's all we need. Correct. So now you're saying it must start with this and end with that. And so when it starts with a 42 instead of a +1 or whatever, or ends with an extension, those don't match. So congratulations, you've just matched a phone number.
Yeah.
So let's go back. Oops. So here's the pattern I came up with ahead of time. Pretty darn similar. I did use a non-capturing group here, but whatever, that's not a big deal. Like I said, I used the set instead to match a dash or a space. The alternation is fine. In this case, I don't think it would really be an issue. Keep in mind the way alternation can be greedy, that that may cause issues depending on the exact pattern and subject you're matching. But yeah, that was good. Time. So this one had a unique problem to it that I think we can I think is an interesting one that I want to have you guys test and solve. So similar to before, we've got our patterns we want to match and our patterns we don't want to match. Do you guys want to try this one again, or should I just explain it? Go step by step. Anybody? All right, I'm gonna go ahead and just talk through this one. So like I said before, whenever I start out trying to match some patterns, I pick one or two of the simplest patterns to match and go with those. For example here, I'm going to go ahead and match these first two, 5:30 a.m. and 12 p.m. with and without a space. Those seem pretty straightforward and easy to match. So let's say it starts with a numerical character, one or two of those, followed by a colon, and then another two digit characters, two, and then there's a optional space followed by AM or PM. And that gets us these first two patterns like we said, but now we're also matching one of the ones we don't want to match. Let's move on and add 10:10 a.m. to this and 2:45 p.m. to this as well. So basically the only difference between these and this that's different is the AM and PM are lowercase. And instead of using, you could do this AM, PM, and that would work. I'm going to go ahead and change this. I personally like sets over alternation when possible. So I'm going to change this to capital or lowercase a, capital or lowercase p, followed by capital or lowercase m. That gives us those as well. Now we can easily add on the 4 p.m. here by making this group optional. So we make this optional right here. This whole group is now optional. That gets us that.
Is there a way to make a set, so like your AM PM, is there a way to make just that part case insensitive without having to type multiple letters?
Yes, there is, and I didn't put it in this presentation on purpose, but I believe it's like, I think it's something like you give it a question mark, no, I don't remember. There is a syntax. It's like a grouped syntax, something, and that was it colon I? No, I don't remember.
Double bracket colon lower.
Double bracket. Oh, you
double
could
square brace.
like that.
Lower needs to get wrapped with the
No.
colon.
So this is one of the cool things about this is they've got a nice little cheat sheet here. I thought pattern settings. No, that's not it. There's a reference. Flags. Groups. I don't remember.
Oh.
There is a way I didn't put in the presentation and I forget it offhand, but we can check that out later.
Okay, no worries.
Yeah, it is possible though. Yes, 100%. Where were we? Oh yeah, so we've got all the ones we want to matched, but we're also matching some that we don't want to match. For example, this 13 is being matched here. Obviously, there's no 13 o'clock a.m. and no 10:99 p.m. So we kind of have to break apart these sections a bit. And unfortunately, there's no easy way to say I want a digit between between 1 and 12. Like you can't do that. That's not a thing in a regular expression. It operates on characters, strings, characters, not digits. It doesn't have any concept of the number 13, just the character 1 and the character 3. So in order to address this, we have to break this down and say very specifically what we're looking for. In this case, I'm going to create a group just to make it easy and keep that because what we're going to look for here is the numbers 1 through 9. So you could have just the numbers 1 through 9 here. So there's 1 o'clock, 2 o'clock, all the way to 9 o'clock. Those are legitimate. Or you can have 10 o'clock, 11 o'clock, or 12 o'clock, which in that case is pretty simple. It's the number 1 followed by the number 0, 1, or 2. So we can create a group here. And then that is, wait, what am I missing?
Should be 0 to 2.
0, 2, yeah, thank you. So that says we're going to capture any numbers 1 through 9, or the number 1 followed by a 0, 1, or 2, 0 to 2. And that will eliminate that for us. Okay. And then similar weight with the after the minutes, we can only have the times 0. So you could have 0, 0, because it could be at the hour, all the way up to 59, at which point it rolls over. So with that, we're just looking for the digits 0 through 5, followed by the digits 0 through 9. All right. Why is this still matching? What am I missing? So we've got 1 followed by 0 through 2. Where the digits? Oh, because it's, I know why. So I think the only thing we're missing here now is, as before, we want to constrain this to the start of the string and the end of the string, and that will get us our full match of the formats we're looking for, but none of the formats we don't want. And so if we take a look, I think we matched pretty much exactly what I had there. Again, oh, I did add the optional 0 in case it was like 0, 4. So you could have a 2-digit number that was, or not, that was possibly started with a 0. That's the only difference between this pattern and that, I believe. All right. I'm gonna, what time was it? Yeah, we're already kind of after 8. So I'm not gonna do this one. This one was actually pretty complicated, but it was my filler in case I needed to fill in some extra time. But this example was matching URLs. To start, I was going to go here, which gives a brief definition of what a URL is, like how it breaks apart: scheme, : / the user, the password at host, port, path, a query, a fragment, and even like gives you some more specifics. Like a URL is composed from a limited set of characters belonging which includes 0 through 9, A through Z, upper or lowercase, and a few special characters. So I was going to use this as our definition of what a URL is. Whether or not it's exactly accurate, I wasn't 100% sure, but this felt solid enough of a definition that we could create a pattern off of.
The presentation freeze for anyone else?
I'm seeing his mouse.
Like it's stuck way back at the
what do you see?
RegEx for time screen.
Okay.
Might have to reshare.
Yep. How do I do that? Stop share. Now, okay, so what do you see? Come on, go away. Oh no, I closed it. Where did it go? I lost the presentation itself. All right. Okay. Okay. So you see the URLs now?
Yep.
Yeah.
Okay. And so it's saying, where are we here? So this gave us that definition of what a URL is, breaks it down like the scheme and the user and password, host, port, path, query, fragment, and gives us, like it says that a URL can be composed of letters, numbers, and some special characters. So this is, when writing a regular expression, having a clear definition of what you're trying to match is very, very helpful, because otherwise you can say, oh, I don't know, and just start throwing like, I just want dot stars, which just means match any character all over the place, and your regular expressions quickly get out of hand because you're matching things you don't mean to match, and it just becomes increasingly difficult the more you without that clear definition. So what is going on? Why do I have two windows? Oh man. Go there. All right, so instead of walking through this, basically what I was going to go through is start simple, match something like this. Then we're going to add the schema to it, and then we can capture optional ports and paths and like then this and that, and ultimately we would end up here. Looks like, I mean, this is the thing that, like, when you don't know what a regular expression is and you look at it, and even if you do know what a regular expression is and you look at it and you go, what the hell is that? you gotta take some time to break that down. But one of the things I wanted to show with this with URLs in particular is how naming and grouping things can be very, very useful. So here we've got all of our examples we wanted to match, and I've pre-written the pattern here with named groups. So like your scheme is, here's the group for your scheme, here's the group for your username, here's the group for your password. That whole thing is optional, et cetera, et cetera. But if you, on regexer.com here, what you can do is, if you've got your pattern written and groups and everything set up, you can actually see down below here, if you click into any pattern, what exactly is matched. So this whole line matches, as you see, which will match google.com, but it says there's no scheme is empty, username is empty, password's empty, and there's the host. It doesn't show you any of the other things because those come later in the pattern. Since those aren't there, they don't show up. But you give us like a more complicated one like this one, you can see it breaks it apart here. And so we can see the scheme here is HTTPS, the host is api.example.net, the port is 1337, our path is /sum/page, our query is foo bar baz clux. In this case, username and password are empty, but if we like take a look at FTP, for example, that one will have our username, user, password, versus like SFTP will have a username but no password. And this is where like the power of regular expressions really comes in handy, is you can take these complex strings with varying contents but a known format and define a pattern that says this is a URL. And these are the pieces of a URL. And I want to extract these pieces from those URLs and use them in different ways. You can see these links in detail. I'll have the slides published after this, so you can like look at these in detail. Another thing I was going to do if we had time, but I think with problems and we're already after, getting close to 8:30, was this regexcrosswords.com, which is a fun little game. Just to real quick give you an idea. What this does is it gives you a couple of rows and a couple of columns with a regular expression tied to each of them, and you have to put in characters in each of these sections to make that whole row match this and that whole column match this. I'm not going to get into it now, but this was something I only found when I was researching this presentation, found this, and it was actually took up more of my time than I care to admit. And like every good topic, there's an XKCD of it. You can read this if you want, but basically he's saying how once he learned regular expressions, he's now concocting ideas to come up with ways to use regular expressions to like save the world and stuff like that. And my references, regular-expressions.info was a great resource. I encourage you guys, if you want to learn more, to go there. It's got just like that's just like a place you can go and read, and it'll explain every piece of what a regular expression is and how they work. The PHP manual on PCRE patterns is a good one for PHP specific regular expression stuff. regexer.com is what I was using for these here. And then to make these slides, if you're interested, I used a combination of Reveal.js for the slides and Tailwind for the styles. Anyway, that is it.
No email regex? Come on.
I was, yeah, like I said, coming up with ideas was hard, like actual examples.
No, but like the official regex for email,
Oh yeah.
that long.
Mm-hmm.
It's impressive. Scary.
Any any questions or comments at this point? Like, this is kind of just the surface of regular expressions. There's a lot more to them. Like, very interesting edge cases, and like if you delve into it, like can get complex, and like you want to match like two different things, and you have to write like 30 characters. Sometimes maybe not that bad, but it can. They're very powerful, but complex. Complex comes with that.
Oh, thanks, Chris.
Mm-hmm. Appreciate you limiting the number of brain melting regex patterns. Yeah, I was trying to build you up from here's one pattern, here's two patterns together, here's 3 or 4 patterns together. But that's like when it comes to it, that's yeah, you got to break them down into the as small of parts as possible, and then put those together.
Yeah, really good presentation. Thank you.
Mm-hmm. Sorry about the technical difficulties. I think the problem was, one of the big problems is I normally have my laptop in a vertical stand, so it has airflow, but I put it on my desk so I could have my presentation notes in front of me, and I think it might be overheating.
Thanks, Zoom.
Yeah, that plus Zoom, right?
Yep. Anyone have any other interesting PHP news that's going on?
I
saw there's a new RFC for specific octal integer. I don't remember.
What?
It's like instead of like using 0x for hex, you do 0 small o for octal.
Hmm.
I don't know. That's the only new one I saw. Has anyone played with the new composer yet? Checked out the speed increase?
I haven't yet, but I may try and give it a go next week or something. I don't use any plugins, so I might actually have a pretty straightforward update. I don't know.
Yep. I know a lot of people were using the parallel processing or parallel download plugin that I don't remember the name of, but it sounded Italian. Prestissimo. Yeah.
I removed that before I even updated because I was pretty sure it wasn't needed. But then I ran into issues with the bash completion plugin I use, to which I opened one issue and he quickly updated the API to work with Composer 2.0. But now I'm getting conflicts because it uses some old Symfony console versions, and that's conflicting with other things. But I opened another issue for that, so hopefully that'll be resolved soon.
Nice.
Time to sit.
Faker's dead.
Faker's dead, yeah. Well, no, it's being preserved by Laravel people. They forked it to an organization.
Oh, did they?
Yeah. They were ready. They're like, that was their proposal to begin with, and what brought on the developer saying he's no longer going to do it was from that. So they just went ahead and did the fork and say they're going to maintain it there going forward.
Yeah, I mean, he intentionally said, like, I don't want it to be maintained going forward. I want it to die.
Mm-hmm.
So.
And he gave valid-ish reasons, but I feel like it's one of those things where until we have a good replacement, it's not going anywhere.
Right, but at the same time, Faker's so good, no one's gonna build a replacement for it.
Right. Yeah.
So it's a catch-22.
Mhm.
Yeah, but I mean, having maintained widely used open source stuff, I mean, the best thing to do is, I guess what I did like a decade ago, is just find somebody new to take over and then walk away and not care. Totally rewrote it, that's fine. It's like,
Yeah, he tried that, and it
Cool
didn't work.
cool guys don't look at explosions as they walk away.
Yeah.
I mean, but you have to do that. Like, give away the composer name, give away the domain it lives at, give away the GitHub repo to whoever's going to maintain it, redirect everything to that, and then you're just done with it.
That was his big hesitation. Is he's like, this repo has over 20,000 stars. I don't want to move that out of my name. It's like, yeah, well.
He also brought on 2 people to take care of it for him.
Which
And, like,
sound,
they
did you read the
couldn't keep
blog
up.
post? Yeah,
Yeah.
yeah. They.
But that's
they
kind of
just-
like you went in both ways. Like, I don't want to maintain it anywhere, but I still want to have all my GitHub stars so that I look good.
Right.
Well, that's not the way it works.
I think just having your name tied to the history is, in my opinion, is big enough.
Yep.
Yeah.
See, and I didn't even, I've never used Faker. I didn't even know it existed. The way I've been generating data for test stuff, randomuser.me has an API and you can seed it. So I use a seed that is just an MD5 hash of my class and method name so that my data fixtures go and grab, say, 50 people, whatever locations, addresses, just goes, grabs that, seeds it, and dumps it into my database.
Which is great, but now you're making an API request to seed fake data.
Only maybe once.
Yeah, well,
I mean, it depends on how often you destroy your database.
right.
Right.
In the Laravel world, you're intended to have an in-memory database, so when you run your tests, every time you rebuild your database from zero, like with every test run, and so you.
But
need
in your
data.
test runs, you're not generally seeding it. Like,
Well, your tests, like if you
you're
need to,
migrating.
like if you need a user for like your test, you to run like a test to say
Yeah,
like
yeah, yeah.
assert that I can
Correct.
log in or whatever, you need to
Yeah, yeah, yeah. You
migrate
make a factory. Yeah.
you
for
migrate
sure.
the file and then create a fake user with a fake email address and a fake password. I mean, you could, for a lot of those, you could, if it's very simple, you could manually do that. But sometimes you're like, I need to generate 10 random blog posts to assert that it paginates correctly or sorts correctly or whatever.
Yeah, I mean, the other option you can do is go get the API data once, dump it into a JSON file that you store in your data fixtures directory and read that in when you want to load the data. Then you're not doing the API call.
But then you have a new feature and new tests that require new data. You want to do that manually every time?
You're
gotta
also
do-
limited to the number of users that you created in that JSON file, right?
Yeah.
So for me, when I was building a role-based access control system, I wanted to see how it worked at scale, right? So I was adding 1,000 users and then 10,000 users and then 100,000 users and doing all of that with Faker locally, offline, didn't have to worry about anything. It made things easy.
Or another useful thing is when you want, like, not even like test data, but when you want to manually test something and you like, instead of having to manually generate that data yourself, if you can just quickly Faker generate something and throw it in the database, like with your specific conditions for that, whatever it is you're working on or testing, it's very useful.
Awkward silence.
I'm spent.
I miss drinking with you guys.
Yeah.
Yeah.
That place we went to had decent fish and chips.
Well, we'll get back there, assuming it's still open post COVID.
Right.
All right, I'm getting up early, so I'll see y'all later. Great presentation again, Chris. I'll see you guys next month.
Again, sorry about the technical difficulties. I will be posting a link to the online slides maybe tonight, maybe tomorrow.
Cool. Have a good night, everybody.
I'll try and get the recording done hopefully by the end of the week.
Cool. Send me a link whenever you do.
Yep, we'll do.
All right.
Good night, everyone.
Good night. Bye-bye. See you tomorrow.
What's up, Chris?
Thank you.
See you guys next time.